Hi, I'm Heria from BSEC3A, and I will discuss about polyethylene, buffer, and half-duplex. And these terms are based on my first name, middle name, and last name initial letters, and these terms are all related to fiber optics. So first is polyethylene. Polyethylene is widely used for insulation of cables since it has excellent dielectrics, high dielectric strength, low dielectric constant, and low dissipation factor at all frequencies. This makes it an ideal insulation across a range of different cable types, including telephone and high-speed transmission, high-frequency signal and control cable, low, medium, and high-voltage power cables, and overhead line wire and service drop cables. Polyethylene is suitable for both wire insulation and final cable jacketing. Polyethylene is commonly used because it has a temperature range of -60 degrees Celsius to 80 degrees Celsius, has a good chemical resistance, durability, flexibility, and has an excellent UV resistance. Power consumption in a cable transmission line is dependent on the attenuation of the cable, which in turn is dependent on both the dielectric constant and the dielectric loss factor of the insulation. So moving on, what is buffer? As you can see in the illustration, the buffer coats the optic fiber and protects it from physical damage and light from leaking. So buffer is a material that is used to protect an optical fiber or cable from physical damage and to provide mechanical isolation or protection. Fabrication techniques include both tight jacket or loose tube buffering as well as multiple buffer layers. In a fiber optic cable, a buffer is one type of component used to encapsulate one or more optical fibers for the purpose of providing such functions as mechanical isolation, protection from physical damage, and fiber identification. So, buffer has different fabrication techniques. A loose buffer may contain more than one fiber and sometimes contain a lubricating gel. A tight buffer consists of a polymer coating in intimate contact with a primary coating applied to the fiber during manufacture. Buffer application methods include spraying, dipping, extrusion, and electrostatic methods. Materials used to create buffers can include fluoropolymers such as polyvinylidene fluoride or kynar and polytetrafluoroethylene or Teflon. Lastly, half-duplex. Half-duplex is a type of data flow between two devices in a communication. In a half-duplex transmission, a sender can send the data and also can receive the data but one at a time. It is a two-way directional communication but one at a time. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for each direction. The half-duplex mode is like a one-lane road with traffic allowed in both directions. When cars are traveling in one direction, cars going the other way must wait. In a half-duplex transmission, the entire capacity of a channel is taken over by whichever of the two devices is transmitting at the same time. Walkie-talkies and CB radios are both half-duplex systems.